Hey guys, so today we are going to start with causal and non-causal systems, and this is in continuation with the DSP course. So now first of all we are going to see that what is a causal system. Now it is a system where the output depends on the present and the past inputs but not the future inputs. That is, I've written examples that this is the output and xt is the input. So the output, that is the output of the system, only depends on the past and the present inputs but not the future inputs. Suppose for example I have yt is equal to x of t minus 3 plus x of t, as I have written over here. Now suppose if I put the value of t as 2, so I will have y of 2 is equal to x of 1 plus x of 2. So now you will see that this is a past input as it has a value of x of 1 whereas the output is 2, and this is a present input. That is, we have to look at the x values, that is input values, individually if we have two inputs. So this is the past and this is the present, so this will form a causal system. That is what we have written over here, that the output depends on the present and the past inputs but not the future inputs. Okay, so now let us move on to non-causal systems. Do not worry, we will be doing questions on both of them. So now let us move to non-causal systems. It is a system where the output depends on the future values of the input. So this is completely opposite of causal systems, obviously. So now let us see with an example. Suppose this is the example and we have, this is the output yt and this is the input x of t plus 1. So now how we can write this as? We can write this as y of t is equal to x of t plus 1, and now we will be putting the value of y of t, say 3. So on doing that you will get y of 3 is equal to x of 4. So this you will see is a future input. So this is only possible if we are dealing with non-causal systems. So such an input will be called as a non-causal system, and the things that we discussed above were for causal systems. So now let us move on to a little more detail. Suppose we have the inputs x of 0 and then we have x of 1, then we have x of 2, then so on we have till x of n, and here we have x of minus 1, here we have x of minus 2, and here we have x of minus n. So now guys, you will see that this is the present value, present input, where x represents input. So this is the present input at x is equal to 0, and all these values that will be after x of 0 will be the future values. Alright, and this will be the past values. So now let us define a concept, and guys, you know, whenever a concept comes you have to star mark it in your notebook or wherever you are making your notes. So now first of all we will write the concept number 1, that is, whenever the input gives us a present or a past value, then it is a causal system. And whenever we have future with us, that is, we have future inputs, that is, the output is dependent on the future input, then it is a non-causal system. In this case we the present can the future in this case the output can also depend on the present as well as the past. But if the future part is there, then the system will always be non-causal. It does not matter whether we have present or past, but the future part is there, then our system will always be non-causal. And if we do not have a future, that is, if the output is not dependent on the future, then it will only depend on the present or the past value. In that case, the system will be causal. So now let us write a few more concepts. That is, suppose we have yt, that is the output, and we have c of xt, where c is a constant and x is the input. So now if yt and xt are, that is, they remain the same, that is they remain the same, then it is present no matter what the value of C. So what I mean by this is that suppose we have yt and xt, which is given by this relation where C is a constant, then whatever we put the value of t, say we put the value of t to be 0, then we have y of 0, C, x of 0. So whatever you put, the same value will come over here. So this is the present. That is the output depends on the present input. No matter what you put the value of C over here, we will always get the present input. So this is a causal system, as it only depends on the present and not the future. Now let us move to the second concept, that if a function has, say we have a function, say y is equal to some part of x where we have a certain value of t over here. So now if we have all three states, that is we have the present, the past and the future, then I had told you earlier that what this case will be if we have future value, it will be a non-causal system. If you see a future input that the output is dependent on the future input, then the system will always be non-causal. Please keep that in mind and star mark it. So now let us write the concepts, a little bit of summary at what we have discussed over here right now. First part is that if the output is dependent on the present and the past value of the input, then the system will be causal. And secondly, if we have present and future and say past also, then the system will be non-causal. And I have told you that if you see future, straight away write non-causal, because in a non-causal system the output depends upon the future. So guys, let us move on to questions. Now we will be discussing questions. So we will be discussing questions in the next video, and if you are able to understand this, please subscribe the channel, as it will help me to create more such videos. And if you have to give any feedback, please write in the comment section, and it would be great to know that you are able to understand it. And guys, please, while I'm writing the notes on the screen, you should also keep writing them along with me, so that it helps you to refer to them in the future. So guys, this is it for this video. See you in the next one.